Hi everyone, Ms. Baumgartner here. Welcome to our first lesson video. Today we are going to be doing lesson 1-1 about one variable equations. However, we are not going to be doing it in your Springboard book because that is a lot of hands-on and working with a group, and well, we can't really do that through a video. So it says here that your learning materials are going to be your lesson 1 guided note sheet. So hopefully you either have that somewhere nearby or you printed that off. That's what this is going to follow. Then you'll also need a pen or a pencil and possibly a calculator. Okay. All right. So on the other side here, it says that our learning targets are to create an equation in one variable from a real world context. And then we're also going to solve some equations in one variable. So you guys know that a variable could be a letter like X or Y that is used to represent an unknown, okay? So let's go ahead and get started with example A. Hopefully you are on the worksheet or you have it pulled up to see and kind of can just follow along with me, okay? So it says here, Susan makes and sells purses. The purses cost her $12 each to make, and she sells them for $25. This Saturday, she is renting a booth at a craft fair for $60. Okay, so first thing here, number 1 says to write an equation that can be used to find the number of purses Susan must sell to make a profit of $250 at the fair. So first, let's just start out by thinking about what the word profit means. So profit, right? We've probably all heard of this word. Your profit is going to equal the amount of money you make or you earn by selling purses, let's say in this case. But you also have to subtract the cost or the amount of money it costs to make these purses, let's say, okay? So, and you also might need to, in this case, subtract the cost of renting the booth at the craft fair, okay? So if Susan wants to make a profit of $250, which we see here, okay, that's our profit. So we're gonna put that here, $250, okay? Now, this is where it might get a little bit tricky here because she makes or sells them for $25. So let's start with that price. And now that's $25 per purse. So let's go ahead and put over here that X is going to equal our number of purses. Okay, so let's call this 25X because she's going to make $25 per purse that she sells. Okay, but we also need to subtract here the $12 that it costs her to make each purse. And again, $12 is per purse. We don't know how many purses, so that's going to be our X again. All right, and then the last thing we're also going to need to subtract here is this lovely $60. And again, the reason we need to subtract that is because it's another cost to Susan in order to sell those purses because she needs to rent that booth at the craft fair. So that's pretty much your equation. Now what we need to do is go ahead and solve that. So we should know from Algebra 1 that the first thing you're going to do is combine like terms. So since we have a 25x and a negative 12x or minus 12x, we know that that is going to combine to be 25 minus 12, 13x. Let's just bring down the rest of our equation then. So the minus 60 and the equal to 250. From here, we're going to have to add this 60 over and add it over. So that's going to cancel, and we're going to be left with 310 equals 13x. And then our last step here is going to be divide by 13, because we always do the opposite operation. That's going to cancel. Do it on this side as well of the equal sign. So we are going to get, and this is where you might need your calculator, that 310 divided by 13 is going to be about 23.8, let's say 846. Okay, so now let's look back over here where it said that X is the number of purses. So does it really make sense that she would sell 23.846 purses? No, so let's go ahead and round up and say, okay, to make that profit, she's going to need to sell about 24 purses. And again, when I do that little squiggly equal sign, that just means about. So that would be you solving the equation. Susan needs to sell about 24 purses to make a profit of $250 at the fair. Okay. So then number 3 here says, if Susan sells 20 purses at the fair, will she meet her profit goal? Why or why not? Well, the answer would clearly be no, because as we just solved, she needs to sell about 24 purses, and if she just sells 20, that's less than 24, so she will not make her profit. Okay? All right, awesome. Let's go ahead and try example B. So example B here says, Nick and Sally plan to buy a pizza. The pizza costs $15. They decide to split the cost based on how much the pizza each person eats. Sally eats 2/3 the amount that Nick eats. Okay, so number 4 is asking us to write an equation that can be used to find how much each person pays for the pizza. So first, again, I'm going to start out with saying, okay, this is going to be how much Nick eats plus how much Sally eats is going to equal that total price. Oops. Okay, cool. All right, so let's think about what that would mean. So we're going to say that the variable X, again, that's the variable we're using, is going to be what Nick eats. Okay. So let's just say Nick eats however much, 1X. All right. He eats his whole portion. Plus, Sally eats 2/3 of his portion. So 2/3 X. And that whole total has to equal $15. So now how would we solve for this? Well, again, just like in the last one, we're going to have to combine these like terms because they both have the variable X. So 1 plus 2/3, 1X plus 2/3 X is 1 and 2/3 X. Okay, so now all we would have to do is divide by this. You can do this in your calculator, or if you wanted to, you could write it as a decimal in your calculator, which would be like 1.6 repeating. Or you could also put it in as an improper, so that would be 5/3. But when you do that, 15 divided by 1 and 2/3 is going to leave you with X equals 9. So that means we remember earlier said that X equals how the price that Nick eats. So that means that Nick would have to pay $9 for the pizza. Well, now we have to figure out what Sally would pay. And remember, the whole price was 15. So we can either do 15 minus 9, which is $6, and that is what Sally would pay. Or what you could have done is 2/3 times 9 would also give you 6 for that one to figure out how much Sally would pay. And that would be your final answer there. Okay, so that's another example of a one variable equation. And now let's try one more. Let's try example C. And in this one it says, Marco mowed 8 of his neighbor's lawns. He charged $22 for a short driveway and $37 for a long driveway. Okay, if Marco made $266 in one day, so that would be again like his profit, right? $266 is how much he made. Write an equation that can be used to determine the number of lawns he mowed when, this is important, X of the driveways are short. Okay, so basically they just told us here that X is going to represent short driveways. We're gonna put DW for driveway. Okay, but remember, normally what you would want to do here is say, okay, well, let's think of another variable. Let's use Y for long driveways. But we are solving one variable equations. So now instead of saying Y is going to be long driveways, let's go ahead and put this. We want to think of another way to do this using only X. So this is where you have to think, okay, how many driveways are there total? Okay, well, here it says 8 neighbors. Okay, so all we have to do is, okay, if there are 8 total and X of them are short, then the rest have to be long. So just do 8 minus X, and that's how you can figure out which ones are the long driveways. Okay, so now we should put that all together. So we know he's charging $22 for short driveways and $37 for long driveways. So let's put that together and say, okay, so 22X for short driveways plus $37 is what he's charging for long driveways. And that's going to have to be 8 minus X. So we're going to put that in parentheses. And then we're going to set that equal to the profit that he made in one day, which was $266. So there's your equation. Okay. Now, in part 7 here, we have to go through and solve it. So the first thing I would do is distribute this 37 to both things in the set of parentheses. So 37 times 8 is 296. Again, you may need your calculator there. And then 37 times negative X is going to be a negative 37X. And then let's bring down the rest. So the equals 266 and the 22X plus. Okay, now just like before, we need to combine like terms. So we've got a 22X and a negative 37X. So we would be doing 22 minus 37, and you're going to get a negative 15X. And then plus 296, bring that down, equals 266, bring that down. Now your next step is going to be to subtract this 296 over. Oops, let's move that up. So subtract that from both sides. This is going to cancel. And let's move over here. You're going to be left with negative 15X. And then 266 minus 296 is a negative 30. So we have negative 15X equals negative 30. And our last step here would be divide by negative 15 on, both sides. So that's going to cancel there. And That's going to leave us with x equals, and negative 30 divided by negative 15 is equal to 2. Now, keep in mind, part 7 here, yes, you've solved for x, but it also says to interpret the solution. So when we get x equals 2 as our answer, that means, remember what x equals? It means short driveways. So that means he would mow 2 short driveways. And then remember, to figure out long driveways, you just have to do 8 minus 2, or 8 minus x. So that would mean 6 long driveways. And that's your answer. Okay. So those are 3 very different examples on how to solve one variable equations. Notice in all of them, I just used x. I never used anything other than x, just one variable. Okay, so what I would like for you guys to do is look at these 3, try these problems, pause the video and try them on either your printed sheet of this lesson 1-1 or on a separate sheet of paper. Okay. All right, and finally, here is the work. So for number 1, you should have solved for x, which should have been hours, and gotten about 4.13 repeating, or about 4 hours. For number 2, you should have solved for x, which would have been the number of guests or the number of tickets that they must sell. And you should have gotten x equals 25, so that Dante must sell 25 tickets to break even. And for number 3, this was like example C, and you should have noticed that there were 7 pools total. X should have been for the in-ground pools, and 7 minus x for the above ground. So if you match those charges up, you should have gotten B as your final answer. Okay. So if you have any issues, go ahead and rewatch the video or pause at any point in the video. And if you have any questions, be sure to bring them to our Zoom tomorrow. Thanks. Have a good one.